I'm going to talk about some of the challenges that come with high-speed automation. And the reason why this is top of mind for me is we just recently had two clients come to us and talk us about problems that way. And it is a problem that we've solved for a client in the past. And the specific challenge that I see with high speed, and I mean high speed, 5,000 units an hour, 10,000 units an hour, something that's really putting out a lot of volume. The reason that we see challenges in high-speed automation is kind of twofold. One is when the company buys this, there's a lot of promises from the OEM. Typically, the qualification run of that piece of equipment is done over the course of an hour. And so, sure, you can get, 5,000 units an hour out of it, but is that going to be true over an 8-hour day, over maybe you're running a 10-hour shift, maybe overnight when nobody's around and you're just trying to run that thing at night, you have minimal maintenance staff. So what we see is that any little bits of downtime become a major impact to that estimated capacity. And then you get disappointment from the leadership team who probably spent a lot of money on that high-speed equipment. And so in our past, we attack this, frankly, the way we attack everything. Discovery, study the problem, understand what's going on, look for the small things that make big impacts, work with operators, work with leaders, work with maintenance, and come up with operational changes. And the things that we've seen that really are important in this case is understanding that preventive maintenance. With everyone goes, yeah, we understand preventive maintenance, but do you really? Like, one of the things that we've recognized is that you can have 3 or 4 days of incredible output, and these machines are complex. You're putting a lot of wear and tear on different components. You may be better to use that 4th day to stop and do a bunch of PMing, just replace things proactively so that you don't slowly, and this is what we would see in the data, is the slow drop, the slow decline, and then some big downtime, some big outage that you'd be out for 4 hours or something unplanned. Again, huge deal if you're thinking about you're putting out a lot of volume every hour of the day. The other things are how the operators interact with the machine. And if you're familiar with total productive maintenance, you may already know some of those tools to get operators more involved. Nonetheless, the way you learn what operators are doing or not doing that are either prolonging the uptime of the machine or maybe deteriorating the uptime of the machine is through observation, spending time out there, seeing what kind of wear and tear buildup, issues that are occurring, belts that get worn, all those little things make potentially a big difference in the output of the machine. And so that's what we did with our clients some number of years ago, and we're able to get them from I can't remember, it's probably 70 or 60% uptime through the course of a week to upwards of 90% uptimes throughout the course of the week. That's how we addressed it. And that's frankly why some of our clients are talking to us about this. It's an expensive problem to have, and we really have to utilize those continuous improvement methods to unravel it just like we would any other. So I'm interested to hear from all of you who's dealt with these kinds of problems. How have you attacked them? They seem to be coming more to our attention these days, and I'd like to have a full toolkit of how to address them. So really interested in your thoughts, comments, and experience. Put them in the comments of this post. Thank you.